This video is the second video in which I'm going over how to graph quadratic functions in Vertex form. In the first video, I went over how to do so using a table of values. This video is going to go over how to do it in a slightly faster, more efficient way that requires on knowing some shortcuts and knowing how to change graphs based off of some parameters. So think of this one as graphing in Vertex form, part 2. So to start, just to set up a baseline, we're going to graph our really basic quadratic y equals x squared. This is just going to give us an example with which to work on. So we're going to do so on a grid. And for me, I'm going to go up to 10, down to 2, and then left and right to 5. Specific size isn't super important. We're just using this as a guideline to work with. Okay. And in the last video I made on graphing, I went over how to draw this one. And in our table of values, we used some of these points where x was -3, -2, -1, 0, 1, 2, and 3. And so if you plug all of those into the function, y equals x squared, and you square them all individually, you're going to get -3 squared is 9, -2 squared is 4, and so on and so on. And so we get these x and y values. And so we're going to take those and we're going to put them onto our graph. So we want to put our scale on there. We're going to want to label our axes real quick, just so that everything is super clear. And then let's go ahead and plot ourselves some points. So we've got the point -3, 9, -2, 4, -1, 1, 0, 1, 1, 1, 2, 4, and 3, 9. And it gets us this parabola. And drawing your parabolas this way, making a table of values, is totally fine. It'll work you through pretty much every situation, but it's not necessarily the fastest, especially when you have to go through and do a bunch of complicated calculations. Knowing the patterns and how they apply to each individual function can make this process go a lot faster. So what we want to look at is the pattern these points make from our vertex. So our vertex is right here at 0, 0. Then for each point, we're going over a distance and then up a distance from the vertex. So we go over 1 and up 1. Then we go over 2, again from the vertex, and we go up 4. And do it again, over 3 and up 9. Right, so our vertical distances are just the squares of our horizontal distances. 1, 1, 2, 4, 3, 9. Here's the thing. When we were looking at the effects of the parameters on our parabola, a, p, and q, using Desmos, we saw that changing different parameters did different things. When I changed p, I moved the graph side to side, but notice that the shape of the graph doesn't change. And so if, say, I move it over to here by making p3, if you look closely at those points, you'll see that that same pattern of over 1, up 1, over 2, up 4, and over 3, up 9 is still there. Moving the graph hasn't changed that. And same thing if we move it down a bit. Maybe we bump it down to -4 or so. You can still see that same pattern. So changing p and q hasn't changed the shape of our graph, it's just moved it to a different place. Versus if we change a, we do know that that does change our graph, changes the shape, and that does affect the pattern. Though, keep in mind, it doesn't affect the vertex. So knowing all of those things, we can use this basic y equals x squared graph to help us graph pretty much any other quadratic. And so we'd say that we can graph other quadratics by doing what we call transforming this graph. So we're going to take it and we're going to change it in different ways based off of the information that we're given in our function. So to do so, you need to know that basic x squared pattern. We'll refer to this a lot when we draw graphs. So over 1, up 1, over 2, up 4, and over 3, and up 9. This pattern is going to be exactly the same for any graph when a equals 1, because the shape of our parabola will not have changed. So let's try that out and see how we can use this to draw ourselves some faster graphs. Let's try, for example, y equals x plus 2 squared minus 3. So we're not going to make a table of values. What we are going to do is draw ourselves a grid, 5 by 5, so 5 in each direction should be fine for this one. And then we're just going to graph it. So we're not going to have to calculate really anything. We're just going to have to do some counting, and we're going to have to know that pattern. So the first thing we want to do is start at the beginning, which is our vertex. So step 1, plot your vertex. Remember, from what we've seen in past lessons or past videos, we can get the vertex from P and Q. So P and Q in this case is going to be -2, not +2, and -3. So this is our vertex down here, -2, -3. For the rest of the points, since our A value is just 1, we can use the exact same x squared pattern to get all of our other points. Keep in mind, we ideally want at least 5 points. 7 is great. It can be a little bit too much depending on the graph. 3 is typically too little unless it's a really big parabola. So 5 is sort of our sweet spot. All right, so from this point that I've got indicated on the left here, using my pattern, I'm going to go over 1 and up 1, which gets me a point there. I'm going to go over 2 and up 4, which gets me a point there. And if I had a little bit more room, I would go 1 further and go over 3 and up 9. But I'm actually going to run out of space if I do that on this one. And now I'm going to do the same thing in the other direction. From my vertex, which is right there, I'm going to go right 1 and up 1, and right 2 and up 4, which gets me these points. So now we just come through, we draw our parabola through them, and we're done. So now, I'm going to get you to pause this video in a second and try to graph this next one on your own. So y equals x minus 3 squared minus 5. All right, so if we are doing this particular graph, we should be starting with our vertex. So that's x minus 3 squared minus 5. Our vertex is at +3, -5, which is right here. From there, we're going to use our pattern. So A is still 1 in this case, which means we're going to go up 1 and over 1 on both sides. So left 1, up 1, and right 1, up 1. Then we're going to go left 2, up 4, and right 2, up 4. Again, always from the vertex. You're not going from one point to the next. It's always from the vertex and outwards. And then one more time, because we've got some space, we're going to go over 3, left and right, and up 9, which will give me a point here, and one more just slightly off the side of our graph there. And now we come through, and once again, we draw ourselves as nice of a parabola as we can. And there we are. So double check that, see if your parabola looks like it should. And hopefully it does, and we can move on a little bit. The question that obviously comes from this is, well, what happens if A isn't 1? How does that affect my graph? We know changing A can make the graph wider or narrower. It can flip it upside down. So how do we account for that? So let's try that out. We're going to graph a new function. Y equals 2 times x plus 4 squared minus 5. So draw yourself another grid. Just to make sure you have enough space, make this one 7 by 7. So 7 up, 7 down, 7 left, and 7 right. And come back once you're done that. All right. So when the A value isn't 1, like it is here, we're going to use the same pattern, but we're going to have to make a few changes. So first things first, remember that A doesn't affect the vertex. So our vertex here is still going to be at PQ, which is -4, -5. So this is our vertex right there. To adapt for the A value, what we're going to do is we're going to take the same pattern, and we just have to do one small change. All we're going to do is we're going to take the vertical distances, so not the 1, 2, and 3, but the 1, 4, and 9, so the thing that we've squared to get, and we're going to multiply those distances by whatever our A value is. And so in this case, since A is 2, we're going to be multiplying all of our vertical distances by 2. And so that's going to look, for us, something like this. Our 1, 1, 2, 4, and 3, 9. All those vertical parts are going to get multiplied by 2. And so we're going to end up with 1, 2, 2, 8, and 3, 18. And we're definitely not going to plot that last point because that's going to be way too big, but it's there if we need it. Keep in mind this pattern does continue, so we could extend it to 4 and 16, 5 and 25, 6 and 36, and so on, and then we'd have to multiply all of those vertical distances by 2 as well. So this and this are what are now going to inform our new graph. So from our vertex, we're going to go over 1 and up 2 now, which gives me a point here and there. We're going to go over 2 and up 8, which is going to give me a point all the way up at +3. And so you can see our parabola looks like it's been stretched upwards a little bit, because that's what the A value has done. It's made things go up twice as quickly as they did before. You can think of it, if you like the idea of slope, as being basically like you've increased the slope of the line so it's going up faster. It's not slope because it's a curve, but the idea is roughly the same. And so we've ended up with this. Hey. And to finish things off, I'll give you one more of these to do on your own. This one's going to have a decimal in it just to make things a little bit more complicated. So take this function, y equals -0.5 times x minus 3 squared plus 2, and try graphing this one on your own. Think about what that decimal will do, and think about what the negative will do. They are going to affect things in some way. So graph that on your own, and then come back and see how you did. All right, so keeping with the same pattern, our vertical distances are now going to be getting multiplied by -0.5, because that's our A value. So based off of what we know of A, when it's positive, the graph goes up. But since A is negative this time, our graph is going to be going downwards. That's the only thing the negative really affects. The A is going to make our graph pretty shallow. So big values of A make it go up quickly. Small values of A make it go up slowly. So we're going to multiply all of our vertical distances, this time by -0.5. So instead of over 1 up 1, it's over 1 down 0.5. Instead of 2 and 4, it's now going to be 2 and -2. And 3 and 9 is now going to become 3 and -4.5. So all we have to do now is go back to our graph, plot that point for our vertex, and then plot some points on either side, and then we'll be done. I'm going to reuse the same graph here because I left myself some space. So our vertex is at 3, 2. And then using these same numbers, we're going to go over 1, down 0.5, over 2, down 2, and over 3, down 4.5. So 0.5 on each side, and then 2 on each side. And you can already see it looks pretty shallow. And then over 3, down 4.5 will put me right there and right there. And so once more, we can go through and draw ourselves a parabola for this. I personally find that when they're shallower like this, it's actually a lot easier to make it look good. It's the steep ones that I find a lot more difficult, but that's just me. And there we are. So that is how we can graph our parabolas faster without having to do a bunch of tedious calculations and getting points. So once you've had some practice with this will be a lot better for you, hopefully. But don't feel obligated to do it this way. If you would rather stick with making a table of values, that's totally fine. And sometimes a table of values really is your only choice. Okay. In the next video, I'm going to show us how to go backwards. So how to take a graph and turn it back into an equation.